Hello there, welcome to another tutorial on the Hammer Editor. This time it's on leaks and some basic map optimization. We have a decent amount of stuff to cover today, but before I do, I'd like to make a correction from last video. As I've said in the last video, the projected texture is basically dynamic lights, but I forgot to mention that there's a limit of 1 of these per level. You could change this if you have a source mod, but that's something I'm not going to dive into with this series. But anyway, let's get into the video. I have the comment that told me about this because I forgot to edit in the editing process. I'll put it up on screen right now. First up, let's talk about leaks. A leak is when the inside of your level leads into the void. For example, if your skybox has holes in it that leads into the void, that's considered a leak. Some versions of Hammer have the compile window color-coded, while others don't, but they both show that you have leaks to your level. If you think you do have leaks, look for this text line that I'm showing on the screen in the compiler. So, how do we fix that? Well, instead of going and using the camera to look around and find it, which will take 10 decades, there's another way you can do it that's pretty easy. On the top of your screen, go to your map tab and go to load point file. If you have a .lin file, that means your level has a leak in it. Double click that and this red line will appear on the grid as well as being shown in the camera. This line is basically a guide to where your level is leaking. The line will always go from the nearest entity by the leak to the place that the entity is leaking at. Although, if you compile a map, it will tell you what entity is leaking. Once you find a hole, simply patch it up and make sure it's not leaking to the void. It's pretty important to note that some of the branches of source will not compile a map if it has a leak in it. For example, Left 4 Dead, Portal 2, and CSGO engine branches all required a map to be fully sealed in order to compile fully and be playable. Also, recipes Global Offensive, you will be missed. However, if you're mapping for TF2, Half-Life 2, Gmod, or Counter-Strike Source for example, sealing map is also a need and very important to ensure stuff like 3D skyboxes work. Too long to listen, just seal your maps, guys. Alright, now let's talk about map optimization. Firstly, let's talk about nodraw. Nodraw is a texture that basically makes the face of a brush invisible, while still having collision properties, for example. Using this texture will help you optimize your maps for lower-end hardware and make it so your gamer mod uses up less system resources. The reason why it optimizes your map is because it puts less work on your GPU, since it must render textures for that face. Nodraw removes the texture and makes it so your GPU is not being used to render that texture, which is basically unnecessary depending on where you put it. Now, here's 2 rules I want you to keep in mind before we move on. Firstly, from now on, make all your brushes out of nodraw texture first. Got it? Okay, great. Now secondly, only use this texture in the places the players will not see. This is because it might be very distracting and give a headache during experience due to the texture potentially leaking to the void, which looks terrible and probably will hurt your eyes. But you might be asking, how do we change the texture of an individual face? Well, that's quite pretty simple. Remember how I briefly mentioned the texture application tool in my second video? Well, let's use that now. We won't learn everything this can do today, but we'll learn what we need for today's video. Firstly, let's select the brush and then select the tool. Once this window is up, we can control click each face of the brush we want to change the texture for. Afterwards, we can change the texture by clicking on a browse button on the tool. From now on, I will call the texture application tool TAT. Click the browse button and find the texture you want and click apply. Again, the TAT has a lot more uses, but this is probably the use case you're going to use the most outside of displacements, which we'll go over in the future video of the series. That's how you change the texture on one face of a brush. Pretty simple, huh? Well, let's talk about the portal file. This file will appear after you've compiled a map and is generated with one of those compilers Hammer uses, which in this case it is VBSP, I think. There's probably a more technical version of what I'm about to say, but the general idea is that you want these blue lines to bounce and curve as little as possible. A way you could do this is by making certain brushes into a func detail entity. This would make the portal completely ignore the brush and overall make your map slightly simpler to render, which leads you to a faster compile time. This is also how you turn brushes into entities in general, but we'll go over more uses for this in the future. There are a lot of forms of optimization, like prop fading and area portals, but those are a little too complicated for this video, and aren't really needed too badly when you're learning the basic toolset. We will 100% come back to this topic in the future though, because it is extremely important, but this is really all you need to know when you're making your first map. Most map optimizations come when you're usually basically fully done with your map and are about to release. But doing what I said in this video will make sure that the compile times aren't a huge problem during development and are good for future proofing, because you do not want to not do these 2 things when you're fully done. Anyway, that's pretty much it for this episode of the series. Like I said, there are some more things than map optimization, but we'll go over that in the future. If you ever need help with anything, ask me via my Discord server, that's in the link in the description. Anyway, I'll see you guys in the next video.
Bye-bye!
Throwing flashbang!